FSC 3a, an introduction to food science and chemistry labs. There'll be a couple of lectures in this FSC 3 series. This is the introduction. So we'll talk a bit about the timetable. Talk about the models of how we're going to do the practical sessions. Hopefully we'll all be able to get in the labs, but social distancing measures may still be in application, particularly in semester 1, and we do have plans for how we're going to deal with that, both in terms of the immediate future and making sure you do some appropriate practical work in the future. Other things we'll talk about here are the pre-lab work you need to do, including risk assessments and things like aims and hypotheses. If we can't get in the lab, what we'll do is we'll generate some lab results for you to play with. I'll talk about how that's done in a short while. Hopefully we can get in the lab, so we'll talk about recording information in the lab, which is something we started to do last year, but we're now going to be doing it on a much more formal basis. Okay, formative review of the lab books. If we're in the labs, the staff will review your lab books, and if not, it's a moot point anyway. But we'll start to talk a little bit of detail here about lab reports and the standard format for them. But there will be probably the third video in this series. We'll go into much more detail about what we want into them. And then we'll talk about the marking scheme, which is probably familiar to the ones you've seen from me and other people in previous years. Okay, that's what we're planning to do. 3 weeks with a scheduled practical, and then the final week, week 6, a catch-up. It'll be done in the chemistry labs, and hopefully we'll be able to do all of them. If not, we'll find other models. And these are the 2 models that we're planning, so you can stop the video and have a read through there. I'm not going to go through it in detail, but we'll notice the main differences between lab work proceeds as normal or simulated results are provided. That's the only real difference. And obviously we have to look at wider practicalities. So I'll just have a read of that. Okay, pre-lab work. In your introduction, you should be thinking about why questions and also how questions. Why do we care about, in this case, beta-carotene? What does it mean to us? Why is it important in human biology? We get most of our beta-carotene from plants. Why do plants need beta-carotene? How widely distributed is it? What are good sources of beta-carotenes in terms of nutrition? In terms of technique, we'll do some lectures on chromatography and HPLC. There'll also be some videos and other resources you can play with. And then you'll be asked to review the method sheet and the risk assessment. And also the second phase of this lecture will be on lab safety in general. Yeah, so some pre-lab work, read lecture notes, read around the topics, understand beta-carotene in this case, understand a little bit about HPLC. As I mentioned, think about why we care about it and how we're going to do it, about how we're going to do the experiment. That is the method. Find the risk assessment, review it, and handwrite the COSHH summaries in your lab book. We'll have a look at COSHH in a second. Okay, the information will be available in the labs and also via the intranet. The intranet might have a different title next year. It's still SSE Intranet, although we have merged into the wider school since then, but it's still that. But it may have changed by next year, but it'll be flagged up anyway. Yeah, so COSHH, Control of Substances Hazardous to Health. It's a risk assessment we always have to do when we're using substances which are potentially hazardous to health, or we're using microorganisms which are potentially hazardous to health. Now, it's quite a big summary. You can download the risk assessment, have a look through it, but ultimately it comes down to a couple of things. The conclusion in terms of the hazards, what the problems are, and the handling, how we're going to mitigate those problems in practical terms. And yeah, so there's a summary there for looking at polyphenol oxidase and other enzymes in green tea. And you handwrite the summaries in your lab book. As you probably know, I don't mind you photocopying or printing out methods and pasting them in your lab book, but you must handwrite the COSHH summaries. This is a legal requirement. Okay, in the normal lab, students will be working in small groups of that size. We'll collect the results, we'll share them during the lab. In fact, we'll collect them in the lab. We'll probably collect them in a lot of cases on computers, but we'll plot graphs in the lab. We'll look at calibration lines during the course, and academic and technical staff will be present to talk about both the techniques and your results during the lab. So plenty of support there. If we have to do it the other way, we'll come back to that in a second. This is getting into some perhaps this slide should have come a bit earlier. Again, think about what the aim of the experiment is. Your generic title might be vitamin C in orange juice, but that doesn't tell you very much. The specific aim here is to determine the concentration of vitamin C ascorbic acid in orange juice using HPLC. So all these experiments will have quite general titles. You need to think specifically about what the aim is, which then leads us to the hypothesis. There's a lot of technical material and hypotheses, and it's sometimes a little bit hard to get your head around, but basically we're testing from a philosophical point of view. We always test to check whether something doesn't work. So that's our first position. So our null hypothesis is that we're trying to disprove the hypothesis that increasing sodium bicarbonate content does not increase browning. So we're trying to disprove that, which will prove the alternative hypothesis. Increasing sodium bicarbonate content does increase browning, in this case in biscuits. So once you think about what you're trying to do with the experiment, and not all experiments have a hypothesis, it has to be said. This one does, because we've got a particular hypothesis, does adding sodium hydrogen carbonate to biscuits increase male-eyed browning. But sometimes we're just collecting results and there isn't a hypothesis as such. So talk about this to staff, talk about this to me and other people, and we'll decide whether we need hypotheses. Okay, if we can't get in the lab, we will simulate some lab results based on good sets of previous data. We'll distribute them again via Blackboard, and you'll work in typically small groups of the same size and review them probably offline in Teams or something like that. We'll be available either live in person or in online forums in the usual ways we did throughout most of semester 2 in last year. So what we do basically is this. I've got a good set of results there, both for a calibration line and some samples for beta carotene again. And I use an Excel function called run between to generate some simulated results within a reasonable range, maybe plus or minus 5% of these good sets of results. So all results, you'll get several different sets of results, but there won't be ridiculous results. And as I've said before, I'm not worried about ridiculous results. What I'm more concerned is about understanding the process, reporting what you've done, and thinking about your results and thinking about how you can improve them. And again, we'll talk about that a little bit later on in one of the lectures in this particular series. Okay, now we'll be optimistic. We are going to record information lab, which we've done in the past, but now, as I've said, we need to be a bit more rigorous. We're getting to the point where people may be thinking about doing this sort of thing for a living, and when you do, you'll find there are legal requirements placed on you. So there's some required content there. I'm not going to go through it. You can pause the video and have a read about this. We'll have a look at some of the highlights in the rest of this particular video. Here's one I'm sure I've mentioned before, and you will use a lab book. You bring your lab book in the lab. As we've mentioned before, it needs to be a hardback book, not spiral bound. You write results in your lab book, not in your hand or a bit of paper. You write results as soon as you get them. If you're in the lab book, staff will check that you've done this. Be clear about what recorded. So we don't just have a list of numbers like we have on the left column there. On the right column we have sample plus dish, gives a particular weight and etc. other information which led to that. When you do calculations, remember we have done some discussion about significant figures in one of the early lectures on chemical analysis. Right, okay, where are we? There we are. Yeah. Okay, so summarising results. Some students put all the results in the results section. You don't need to do that. What we're going to see is summary. So here's a typical HPLC result for beta carotene. And the final peak you have there at about 16 minutes is actually beta carotene. We don't want to see a lot of these pasted into your lab book. You can paste one or two in the appendix as an example. What we really want to see is just a nice table. That's a good table. It's got table headings, it's got units. What it doesn't have is a number and a description of the table. And you should remember that all tables, all graphs, all images should be numbered and have a brief description of what they are. Yeah, as I mentioned before, if we can do it, we will review your lab books in the lab. In the past, we've always done marks for this, but as we don't know whether we're in the lab, I'm going to exclude this from the marking scheme this year. If we can do it, we can do it. If we can't, well, we'll come back and look at this in the future. And of course, you can talk to us in various sessions. Okay, lab reports. As I mentioned, this will be a heads-up review of the sections, and I'll go into detail probably in the third part of this series of videos for lecture 3. So there's a standard format as normal. those of you who haven't seen my video on creating a standard document in Microsoft Word, there it is. It needs to be Microsoft Word, not OpenOffice or anything like that. That can cause problems. You can download the Microsoft Office suite for free, so take opportunity of that. It says a maximum of 2,000 words. It's 2,100 or 200. I'm not particularly worried. If it's 1,000 or below, unless it's very well written, you probably haven't done enough. And we notice that it excludes things like headings and tables. That doesn't mean you can stick all your information in the table. Tables should be concise. It doesn't include references and should be presented in professional format and written in professional language. We're going to start talking about here, but I will talk about more, as I mentioned, in subsequent lectures of subsequent parts of this lecture. Okay, so there's the overall structure. Got a cover page, table of contents, the body of the essay, references, and then maybe some appendices. The various reasons why you might want to include appendices. So we'll go through these sections again in more detail, and we'll just review them briefly here. So your cover, it's always a good idea to have a proper cover page. Your name on it, your student number, your module, your title, and the submission date. Maybe the date in which you did the experiment as well. And the table of contents. If you've got that video, I referenced a couple of slides back, it will show you how to auto-generate a table of contents based on headings. You do need page numbers as well. And if you don't have them, you will lose marks. Or more technically, you've lost the opportunity to gain marks. But it's a great idea to base your table of contents on headings. Because however you play about with them, it will update automatically. So the boxes just appeared there. You might have heading 1 and different subheadings. If you change them around using headings, when you update your table of contents, they will automatically update, which is a great time saver. Some there on sort of body text and whatnot. Should be 11 or 12 point Arial at times. 1.5 line spacing purely because it makes it easy for staff to read. And as I mentioned a couple of times, use headings and subheadings. Allows you to generate your tables of contents and also demonstrates that you have thought clearly about the structure of your report. Okay, at the start of the report, I mentioned that when people who do this for a living, they have certain legal constraints placed on them, which we're going to consider there as due diligence. So what the purpose of the experiment was, who was involved, the full names of the team. We just don't want Fred or Ming or anyone like that. We just want your full names, the COSHH information. And it's always a good idea to include a list of the chemicals and a list of the equipment. You'll see this in papers. It's something everyone does. Just use as condensed a list format as you can. Don't do a bullet point list. Just do as a continual list separated by commas is probably best. Saves a bit of space that way. So the body of the report, which as I mentioned, we'll go into more detail in part 3 of this lecture. The introduction, why and how, methods based on the methodology which will be provided, and any changes we make. Your results report in an appropriate fashion, which we've talked about a few times in previous lectures, and we'll revisit in the context of practicals in part 3 of this. Similarly for calculations. So your discussion will look at your results probably in the context of other published work as well. Now again, as I've mentioned a few times in this lecture series, food is incredibly heterogeneous, so don't worry if your results don't look like McCann's and Widdowson's or someone else's. Not particularly bothered about that, providing you've gone through this process. But then you will do critical analysis. Look at your experiment and think about how it could be improved. We'll talk about this more in future sessions. Then of course your references and citations done to Harvard format of course. And then if you have any appendices, this is where you'd place them. Okay, so the marking scheme, based on the usual marking scheme we have, structured through the presentation. Now, as you know, I tend to break this down in this format, so it's very clear what you need to do and where you've gained marks or failed to gain marks. Okay, thanks. That's all I want to say for this. We'll be back in a while with something about safety.